Hi all, I've received a couple questions about this one homework question for this week, and both the students seemed confused about it, so that means maybe there's something wrong with what I delivered to teach this concept. So I'd like to go over it. I'm recording this video just to go over this one problem, and I'll send this to everyone via email shortly. So the Crown Bottling Company has just installed a new bottling process that will fill 16-ounce bottles of the popular Crown Classic Cola. Both overfilling and underfilling problems are undesirable. Underfilling leads to customer complaints, and overfilling costs the company money. In order to verify that the filler is set up correctly, the company wishes to see whether the mean bottle fill, the average, is close to the target fill of 16 ounces. To this end, a random sample of 34 filled bottles, there's our N, is selected from the output of a test run. If the sample results cast a substantial amount of doubt on the hypothesis that the mean bottle fill is not the desired 16 ounces, then the filler's initial setup will be readjusted. So what we're trying to prove, we want to see if there's significant evidence to show that the average is not 16 ounces. We don't care if it's under or over, both are issues. So we're trying to prove that it's not equal to 16. We hope it's 16. We want to see if there's evidence to support our claim that it's not equal to 16, okay? And this is done a lot of times, in quality assurance areas where we can't look at everything, so we look at a sample. So this would be equal to and not equal to. I think simple enough. I think everyone's understanding that. Suppose the Crown Bottling Company decides to use a level of significance equal to 1%. And suppose a random sample of 35 bottle fills is obtained from the test run of the filler for each of the following 4 sample means. So we're saying, what if we sample 34 and the sample mean comes out to be 1606? And then the second one is, hey, what if we sample 34 bottles and it comes out to be 15.97, so forth and so on. Is there enough evidence when we get those results to say, hey, we need to adjust our machine? Assume that the standard deviation is equal to 0.1. So the first thing I need is if we go to, let's just go to Canvas here, and under Files, under Dr. Miko Files, and we've been working with this, the teststatistics.xlsx. Okay, that's the workbook that we use for hypothesis testing. And what we're using right now is we're using z-test mean because we know the population standard deviation. But let's do the first one, okay? We are trying to prove it's not equal to 16, so that's where that would go. The alpha is 0.01, so that goes there. The sample size is 34. The population standard deviation was given as 0.1. The sample mean in this case, well, let's see what the first one is. The first one it's asking me to look at is 16.06. So I'm going to put in here 16.06. It says the evidence as far as z-statistic is 3.50. Okay, 3.50. If I look at 3.50, okay, that looks like the right answer. The p-value, the evidence, now remember, what I'm doing here is I'm trying to prove not equal to. So that means there's evidence on both sides. So that's a two-tail test. So the two-tail p-value is right here. Now, I think when I first opened this up, I noticed it might have been just 2 decimal places, or maybe it was 3 decimal places. So you may be seeing 0.000 and you're like, oh, that doesn't give me the right answer. It looks like this problem wants me to round my z-value to 2 decimal places and my p-value to 4 decimal places and my confidence interval to 3. So let's go out here and let's add another decimal place. And we see it's 0.005. That is the right answer. So there's the z-value, there's the p-value. So what that's telling me is there is significant evidence to prove that it's not filling these bottles with an average of 16 ounces. So that means I need to readjust that machine. Now, we want to go a little further. Okay, it says calculate out a confidence interval. What if we were to estimate the average amount of fluid put in these bottles? So we're going to have to use, instead of the test statistics workbook, we're going to use the estimator's workbook, and we're going to use z-estimate mean. Once again, I'm going to plug in my sample mean. I'm going to plug in my population standard deviation. I'm going to plug in my sample size and my confidence level. That gives me a confidence interval of 16.06, and or plus or minus something, and it wants a confidence interval of 3 decimal places. So let's go to the estimator workbook, and what do we have here? I added a bunch, but we want 3 decimal places here, and we want 3 decimal places here. So our lower confidence limit is 16.016. Our upper confidence limit is 16.104. That's the answer. And why it's readjust is because we want it to be, we're 99% confident that the true mean is somewhere between 16.016 and 16.104, when we really hope this thing is filling it at 16 ounces exactly. Because 16 ounces isn't in that range, that means, hey, it doesn't contain the 16 ounces, 16.00, we need to readjust. Let's look at the next one. Let's do the 15.97. So all I'm going to have to do is, for both of these, I'm going to change my sample mean to 15.97. The p-value it gives me here is 0.0802, not quite enough evidence for me to reject the null in favor of the alternative. That gives me a z-statistics of negative 1.75. Further, if we plug that into our, 15.97, it tells me my LCL is 15.926, my up UCL is 16.014. Because that range does include, because 16.000 is in that range, I'm thinking this machine's working okay. There's not enough evidence to say it doesn't. The value I want it to be filling it at is 16.00 ounces exactly. It's in that range. I'm fine. I noticed as I did this as well, if I do the next one, you'll see it's not going to be right. The connect is wrong for this one. So 16.02. It gives me a z-statistic of 1.17. That's correct. But the p-value that show correct answer, yeah, I think this, yeah, it's the correct answer, yeah, is 0.2435. And I don't know why that says 0.2402. What did I use there? 16.02? And I'm not sure why that doesn't match up identically. I do not know. So that's why, I don't know why that, I think that one just is a bad key, and so I'll fix that one. I'll have to go through and fix those. Let's do the next one. The next one is, well, let's just put 16.02 into my confidence intervals in my estimator workbook. And it says 15.976, 16.064, because 16 ounces in there is in that 16 ounces even is in there. I don't readjust, okay, and that's what it says, do not readjust. The next one is 15.91. Let's put in 15.91 in our z-estimate mean, 15.91, 15.866 to 15.94. Hey, that 99% confident that's producing things less than 16 ounces. The 16 ounces isn't included in that range. So I'm going to readjust for that one. So I hope that makes sense. It does look like there's a key problem with this one. Maybe that's what's causing you guys some confusion. But hopefully this video helps you understand this problem. Okay, so thank you very much, and I'll talk to you soon.